Okay, so thank you for joining me with this video. I'm picking up with problem number 42 on the study guide that's found under the exam review module. Um, the previous problems I have gone over in Zoom sessions, so those recordings can be found under the Zoom cloud recordings for the course, and that will cover over the course of the 2 days we had gotten through about a problem 42 here. So that's where I'm going to be picking up today. So if you're wanting to look at any of those other problems, you need to access them by going to those recordings. So on 42, this is an inequality, a rational expression, a rational inequality that you're going to be asked to solve. So in order to solve this, this is one that you need to find your cut points. So you get the cut points by setting the numerator and the denominator each equal to 0 and solving. This one's a linear expression, so a linear equation, so you're able to solve that and get -3/2, which is one of your cut points. The other, you'll factor your denominator, and when you factor it, you're going to get x plus 5 and x minus 3. Set those equal to 0, and you'll get -5 and +3. So we have three different cut points that I'm going to put here on this number line. So basically, this is dividing it into four intervals. One interval is from -infinity to -5. One is from -5 to -3/2. The next one is from -3/2 to 3. And then the final one is from 3 to infinity. So I want to choose test points from each of these four regions. So I chose -6, -2, 0, and 4. What I want to do is I want to take and put those test points into each of the factors that I have for this expression. So I have 2x plus 3 in the numerator, and the denominator I have an x plus 5 and an x minus 3. So I'm going to break that into each of those three factors, and then I have the combined function together, putting all these together. So if I put -6 into this, I get a negative. If I put -6 in here, I get a negative. Put -6 in here, I get a negative. So I'm going to have a negative divided by a negative times a negative. So I end up with a negative for the overall sign here. I repeat that process for each of these test points, plugging into each one of these. Remember, if I have three negatives, if I have an odd number of negatives, it's going to be negative. If I have an even number of negatives, it'll be positive. So once I've done that, then I need to look back and see, here I'm looking for greater than or equal to 0. So that tells me that I need the positive regions. So my positive region is this region and this region. So from -5 to -3/2, and then from 3 to infinity. Okay, I'll look over here. Infinity always gets a parenthesis, but I have to decide on these others. If it's coming from the numerator, it's going to get whatever this sign is here. So since it has a bar underneath it, then the -3/2 is the one coming from the numerator. So it's going to get a bracket on it. The ones coming from the denominator are a little bit tricky because it can't actually equal -5 or +3, because if it did, I would get 0 in the denominator and I'd have a division by 0 error. So I'm going to need to put parentheses on each of those that are coming from the denominator. So the numerator ones just follow what the sign is. The denominator ones will always be parentheses. Okay, 43 I actually covered in the last video, the Zoom video session. All right, here's one. I would suggest that you've tried these and then you listen to my commentary. So I would pause each one as you come to them and try them, and then kind of listen to what I say about them. So this one isn't, it's talking about investing and it's compounded continuously. So this is the equation for continuous compounding. P is my principal, so that's going to be 10,000. E, we just leave there. Your R is your rate, but be sure to convert that to a decimal. And then your T is your time, so in this case it was 10 years. So put that all in your calculator and you get that as your answer. Okay, so you should have 12,214.03 as your answer. Okay, here we have one dealing with radioactive decay. Right, the first one, find the mass at time t equals 0. So that's just plugging 0 in and evaluating that on your calculator. When I put 0 in here, this expression would be e to the 0. Anything to the 0 is 1. So I end up with just 15 as my answer there. Find the mass at time t equals 20. That's just plugging 20 in and evaluating that, and I get 10.465 kilograms. The last one, how long will it take for 10 kilograms to remain? This one's a little bit harder. So if I want 10 kilograms to remain, then this is going to be where I put the 10. So I'm going to put 10 in here. So 10 equals 15e to the negative 0.018 t. So I'm left to solve this equation, and that means I've got to get t by itself by getting rid of each one of these progressively. So the first thing I want to get rid of is the 15. I can just divide that away. So from here I'm left with 10 over 15 equals e to the negative 0.018 t. If I want to get rid of the e, the next step would be to take the natural log of both sides, and that's what I've done here. So taking the natural log of both sides, I have the natural log of 10 over 15. These cancel, and so I'm just left with negative 0.018 t. Again, I'm trying to get t by itself, so my last step is to divide away this number. So this is my expression here. I'll go ahead and put all of that in the calculator, and I get 22.5 days for my answer. Okay, here are some expressions to evaluate. Okay, the first one here, rewrite the 1 over 8 as 8 to the negative 1. And then we know that 8, if I did the prime factorization, would be 2 to the third. So this becomes 2 to the negative 3. And some of you may have been able to go straight to saying that this is 2 to the negative 3. If not, then kind of follow this progression. You remember we have a property that says if this base and this base match up, then they cancel. We're left with that exponent, which is negative 3. Here, if you remember, the square root is the 1/2 power. If it had been a cube root, it would have been 1/3 power. So here, these cancel, and I'm left with just this 1/2. If I'm asked to solve for x, that's basically putting it in exponential form. So with exponential form, you start with your base, you raise it to this exponent, and then you set it equal to this number. So 2 to the 5th equals x, and 2 to the 5th is 32, so that's my answer. Here, I have an understood base of e, so e to the 3rd equals x. E to the 3rd is a number, so that's done. And then finally, this property, if I have ln and e together, they're going to cancel each other out and leave me with just that 6. Same thing if I had e to the ln of 5. Those would cancel, and I would just have 5 for my answer. Okay, use the laws of logarithms to expand the expression. Okay, first thing with this, bring this exponent down in front. And then when we go to break this up, multiplication breaks up into addition. So we'll keep the 9 out in front and we'll break this apart. It's acceptable to leave it at this step, but if you want to carry it to this step, that's fine as well. Remember that these problems are just representative problems. So if you, obviously I can't give you every single type of every single problem. So if you feel like you need more practice with law of logarithms or something of that nature, then go back to those sections in your notes and the practice problems that we've done and try some of those, or even some of your old tests. Look at that information there. Okay, so here's one that you're combining. All right, with combining this one, we've got the first thing that you want to do is you want to take these coefficients and move them up as exponents. Okay, so we move each one up as an exponent. And then from there, you want to write log 1 time. So when you're doing a combined expression, you only write log 1 time. Anything that's positive goes in the numerator. Anything negative goes to the denominator. So this one, it's a little bit hard to see, but there is a negative there. So this term is going to go to the denominator. This term is positive, so it's going to stay in the numerator. And then the last step, which is actually not required, is that you change this 1/5 into the 5th root. It's it's going to be acceptable in either of these two forms, not this form because you can't have these, you can't have it spread out into 3 logarithms. Okay, here we're evaluating the expression using the law of logarithms. So with this, you want to, because it's addition, you want to multiply these two things together. So you've got the log of, if I multiply these together, I get 100,000. Keep in mind there's an understood base of 10 here for the common log, and I could rewrite 100,000 as 10 to the 5th power. Our bases match up, and we get 5 for our answer. Okay, on this one, you're asked to find the x. So what we want to do is we've got to get rid of everything before that x. So the first thing we want to get rid of is the 8, working toward that. So we need to take the log of both sides. In taking the log of both sides, that then allows me, by using the laws of logarithms, to take this exponent down in front. Okay, so I have 1 minus x times the log of 8 equals the log of 9. All right, we want to get x by itself, so the first thing I'm going to do is divide this log of 8 away. So I divide both sides by the log of 8. That leaves me with 1 minus x equals the log of 9 over the log of 8. Okay, I want to move the 1, so I'm going to do that by just simply subtracting 1 from both sides. And then that leaves me with a negative x, so I need to get rid of that by dividing by negative 1. So I'm dividing everything by negative 1. Okay, so that gives me a negative log 9 over log 8, and then a positive 1. And if I want to reorder that, I can and put 1 minus the log of 9 divided by the log of 8. Okay, on this one, again, we're solving for the x. First thing we want to do is subtract 1 from both sides. We need to get rid of the e, so we're going to take the natural log of both sides, and we get this cancellation here. Here we're going to subtract 1 from both sides. Make sure that you do not combine the 34 and the 1 together. And then divide by 4, and so we get this expression. Since it says exact, you want to leave it like this. You do not want to give the decimal for it. If it says like round to 3 decimal places, then you want to put that in the calculator and round it to 3 decimal places. So really watch your directions and don't miss a problem just simply because of not following those directions. Okay, on this one, we are going to combine these two logarithms together. We'll combine addition into multiplication, and then we're going to put it in exponential form. Okay, so when I put this in exponential form, it's going to be 2 to the 3rd power equals all of this. Okay, so once I have this, I'll have 8 equals x squared minus 7x. At this point, I can see it's a quadratic. So we know that quadratics have to be solved by setting them equal to 0. So I'll pull this 8 over. This is factorable, so I'll factor it and solve, and I get 8 and negative 1. But if you remember, there is a domain restriction with logarithms, and that is that I can't take the log of 0 or a negative number. So if I put negative 1 in, then I can't take the log of that. So I have to throw this one away. So my answer is just going to be 8 for that one. Okay, so looking at this one's talking about doubling time. It gives us the model to follow. Keep in mind that this n is called n naught or n sub 0 is the initial amount, and then the a is the doubling time. So really it's just reading this and plugging in those values. So our starting time is 2014, so everything's relative to 2014. So in 2014, which is when all of this started, our population was 122,000. So this is going to be the n naught or n sub 0. And then we know it doubles in 19 years, so that's going to be my a. So when I go to plug those in, I have this expression here. So I keep the t and keep the n of t, and everything else is going to be filled in. All right, estimate how long it takes the population to reach 500,000. So that's going to be putting 500,000 here and solving for t, solving for the time. How long does it take? Okay, so we're going to solve for that t. So if I put 500,000 in here, then I'm going to first of all divide by the 122,000. And I just reduce that as a fraction. If you really want to, you could carry it, you could do decimals, just be sure you're carrying it quite a few decimal places. It's really better to preserve it as a fraction there. So next what we have is we need to take the log of both sides so that we can get this t down to work with it. So if I take the log of both sides, then that's going to allow me to bring this t over 19 down in front. So I'm going to have this, excuse me, this numerator here. Okay, so getting the t by itself, first thing I want to do is divide by the log of 2. And then the next thing I'm going to have to multiply by 19 to get rid of this 19. So when I do all of that, I get t equals 19 log of 500 over 122 divided by the log of 2. Put that in your calculator and you'll get 38.7 years. Okay, moving into our work with trig, be sure that you have access to a unit circle for your exam. It's not something I'm requiring that you memorize, but you do need to have access to that so that you can answer your questions. Okay, the first one for the reference number, your reference number for this one's going to be pi over 3, and that's basically, if I'm thinking about this, 4 pi over 3 is over here. This is pi, so your reference number is always the difference or how far it is off the x-axis. So this particular one would have been pi over 3 off the x-axis, and that's where you get your reference number. The terminal point for 4 pi over 3, if you remember the coordinates for your pi over 3s are going to be 1/2 square root of 3 over 2. 4 pi over 3 is in the third quadrant. So in the third quadrant, everything is negative. So we're just going to take these basic coordinates and put negatives with them, and that's going to give me my terminal point. As far as the exact value of the trig function, the pi over 6's have coordinates that are the square root of 3 over 2 and 1/2. 11 pi over 6 is in the fourth quadrant, so that's positive, negative. So we see these signs here, and then sine is always the y coordinate, so that's going to be negative 1/2. Tangent 3 pi over 2, we know that the coordinates for the pi or 3 pi over 4. We know that the coordinates for the pi over 4s are square root of 2 over 2 and square root of 2 over 2. In the second quadrant, it's negative, positive. So tangent is sine over cosine. So we have cosine and sine. So if I divide this by this, they're the same but with opposite signs. So I end up with -1 for my answer. Okay, so on this one, you're given the cosine value and you're asked to find sine and tangent. I set this up using a triangle. You could also set it up using sine squared t plus cosine squared t equals 1 and solving for, since you have cosine, solve for sine, and then you can finish it that way as well. If you do this with the triangles, you have to remember, you draw your right triangle. Cosine is adjacent over hypotenuse. So my adjacent side would be 11 and my hypotenuse would be 61. Set up the Pythagorean theorem, keeping in mind that 61 is your longest side, and solve for that, and you get x equals 60 for the missing side. So when I go to answer these questions, sine of t is opposite over hypotenuse, so 60 over 61. Tangent is opposite over adjacent, so 60 over 11. Secant's 1 over cosine, so I'm really just going to flip this is all I'm going to do there. In the third quadrant, sine and cosine, as well as secant and cosecant, are all going to be negative. So this would be a negative answer, and this one would be a negative answer. Tangent is positive in the third quadrant, so this one was going to be a positive answer. Okay, so amplitude, period, and phase shift for this one. Our amplitude is the absolute value of this number here in front. It's kind of like our vertical stretch, except we don't put a sign with it, so it's going to be a positive 5. The period, you want to take this k here. So the period is 2 pi over k. So in this case, my k is 1, so the period for this one is going to just be 2 pi, which is the standard period for sine and cosine graphs. As far as the phase shift is like your horizontal shift. So this one's going to be to the right pi over 2, or it could even be identified as positive pi over 2. Okay, here we have one, the tangent of pi of x minus pi over 4. So we're going to basically take the standard tangent graph and move it right pi over 4. If you remember, the standard tangent graph has a vertical asymptote at negative pi over 2 and positive pi over 2, and it passes through the origin. So if I'm going to move it right pi over 4, then I'm just basically going to take and shift this point here, my intercept, and then I'm going to shift each of the asymptotes as well. So my asymptote would be at negative pi over 4 and positive 3 pi over 4 once I've done this shifting. So everything shifts, the asymptote shift, the intercept shift, and we have a graph that looks something like this. So when we look at that, this is going to be our correct answer here. Okay, this one's talking about inverse trig functions. So with inverse trig functions, remember that for inverse cosine, you're going to take answers from the first and second quadrants. For inverse tangent and inverse sine, you're going to take answers from the fourth and the first quadrant. Remember, in the fourth quadrant here, you want to write these as the negative of the answer. Okay. So on this first one, if I'm looking for inverse cosine of negative 1/2, I have to think which of the coordinates have an x coordinate of 1/2. That would be my pi over 3's. And since I need it to be negative, cosine is negative in the second quadrant. So I need a second quadrant pi over 3 angle, and that's going to be 2 pi over 3. Tangent is negative in the fourth quadrant, so I need to look in the fourth quadrant for my answer. The pi over 4s are the ones that have their tangent is either 1 or negative 1. So that's why I'm going to use the pi over 4. And then since I need it to be negative in the fourth quadrant, it's going to, instead of writing it as 7 pi over 4, I'm going to write it as negative pi over 4. Okay, this one, to find the degree measure, you're going to multiply by 180 over pi, cancel those, and you get 240 degrees. Okay, this one is well, actually there's two here, sorry. Find the length S of the arc that subtends a central angle of measure 5 radians in a circle of radius 6 centimeters. So arc length is going to be S equals R theta. You just need to remember theta has to be in radians. So if it's not in radians, you need to convert that. So my radius is 6 and my theta is given to me in terms of radians as 5. So my arc length is going to be 30 radians. Number 63, I have a right triangle and I've been given an angle and the hypotenuse, and I'm asked to find the opposite side. So when I look at this in relation to the angle that I'm provided here, I know I'm working with the opposite and the hypotenuse. So opposite over hypotenuse is the sine function. So sine of 30 equals x over 31. Cross multiply and put that in your calculator. Be sure you're in degree mode and you'll get 15.5 for your answer. Okay, on this one, I'm working with a right triangle. Remember, SOHCAHTOA, which is your opposite adjacent hypotenuse, only work in a right triangle. So this is a right triangle. So I'm working with the opposite and the adjacent. So I need to use tangent. So tangent of 37 is opposite over adjacent. Cross multiply. And that means I'm going to end up needing to get x by itself by dividing by the tangent of 37. So 14 divided by the tangent of 37 is 18.6. Okay, a 20-foot ladder leans against a building so that the angle between the ground and the ladder is 71 degrees. So here we have our building. We have our ladder that's leaning against the building, and it's 20 feet. And then we have this angle between the ground. So here's our ground and here's our ladder. So this is our angle, 71 degrees. how high does the ladder reach on the building? So this is the x that we need to find here. So in relation to my angle, I'm working with the opposite and the hypotenuse. So that tells me sine is the function I need to use. So sine of 71 is going to be x over 70. Cross multiply, put that in your calculator. Be sure you're in degree mode, and you get 18.9 feet. Okay, this is when you're asked to find an angle. So again, if this is the angle I'm trying to find, then I need to work with the opposite and the hypotenuse. That's what's given. So opposite and hypotenuse is going to be the sine function. So sine of theta equals opposite over hypotenuse. To get rid of sine, I'm going to do the inverse sine on both sides. So theta is going to be the inverse sine of 15 over 39, or 22.6 degrees. Again, be sure you're in degree mode. Okay, sketch the triangle with the given measures and solve for the missing sides, angles and sides, round answers to 1 decimal place. Okay, so I'm given angle A, angle B, and side C. So I'm given angle, side angle. So that's going to be a law of sines problem. So setting this up with law of sines, it's not our ambiguous case, so I don't need to worry about that part, but I do need to use law of sines. So I'm going to have the sine of B over B equals the sine of C over C. So when you have two angles given, you can easily find the third angle by just doing 180 minus 40 minus 63, and that's going to give me the 77 degrees here. Okay, so that's where I'm getting the sine of 77 degrees over 270 equals the sine of 63 over B. Here you'll cross multiply. I'm going to need to divide by the sine of 77, and I'll put all that in the calculator, and I get 246.9 for side B. Okay, then I'm going to find side A by repeating the exact same process. Here's my C information, and I'm going to put my A information here, cross multiply, and I get 178.1. Okay, this one, if you look at what you're provided with, you're given a side angle side. Side angle side is law of cosines case. So with law of cosines, I've got to find a missing side and two angles. So let's start with finding the missing side first, which would be C. So I would use the C squared equals A squared plus B squared minus 2AB cosine C. Remember, these are on your formula sheet, so you don't need to memorize these. So C squared, I'm just going to plug in, and I have all this information. So when I plug that in, remember to take the square root, and I get 3.555 for my side C. So we'll put rounding to 1 decimal place will be 3.6. Okay, we need to find angle B, so I'm going to use the one that has angle B in it, which is this one. And I'm going to plug in the information that I have. So I now have side B, side A, and I just found side C. I would recommend using the unrounded one here. Even though this is somewhat rounded, it's still carried more decimal places than this is. So plug that in for the C's. When you're solving for this, keep in mind that you want to combine these two together, and that's going to give us this value, and then combine these together, and it gives you this value. So then we're going to subtract this from both sides, and then divide this away, and we get cosine of B equals this decimal. Do the inverse cosine of both sides, and we get 74.7 degrees. Once you have the second angle, you can just do 180 minus the 59 you were given and the 74.7 that you just found, and you'll get 46.3 degrees. Okay, so moving into some of this chapter 7 material, I'm not going to be too hard with this. Just a couple questions off chapter 7 is all you're going to see on the final exam. But with the trig expressions, what you want to do is, looking at this, we want to split it up and work with the numerator kind of separately than the denominator. So we're going to take everything to sine and cosine values. Cosecant is 1 over sine. Obviously, sine is sine. Cotangent is cosine over sine. So we're going to leave this denominator for several steps and just not worry about it for now and work on simplifying this numerator. Here I have two fractions that I need to combine into one, which means I need to get a common denominator. My common denominator would have to be sine. This one already has what it needs, so this one needs the numerator and the denominator to be multiplied by sine, and that's what I've done here. Now the denominators are the same, so this step here is just showing I'm writing sine times sine as sine squared. That's really all that's happening in this step. The next step, I'm merging these two fractions into one. So I have a denominator that's sine of x and combine my numerators together and I get this. The denominators just kind of staying the same throughout. Here, 1 minus sine squared is cosine squared, because remember that sine squared plus cosine squared is 1. So from that, I get sine squared is 1 minus, actually, let me solve it for cosine. Cosine squared is 1 minus sine squared. So I want to replace this 1 minus sine squared with cosine squared. Okay, at this point, I've got two fractions that are being divided, so I'll do keep, change, flip. My sines will cancel, and actually one of my cosines, so I'm just left with one cosine for my answer. Okay, so I had you skip a couple problems on the study guide because we just did not end up having time to do those. But looking at this one here, you want to solve it for all solutions. So this is the one where you have to put the plus 2 pi k to kind of take care of all solutions. So on this one, we're going to solve it and get sine by itself. So that means adding 1 to both sides and dividing by 2. And if I'm going to solve this, I need to remember that sine is, because I'm not really restricted anymore. So sine is positive 1/2 for the pi over 6 angles, and it's also positive in the first and second quadrants. So I need my pi over 6 angle from the first quadrant, which obviously is just pi over 6, and I need my pi over 6 angle from the second quadrant, which is 5 pi over 6. So basically I have two places on the circle, one here at pi over 6 and one over here at 5 pi over 6, where the y coordinate or the sine value is 1/2. So to give all solutions, obviously we go around this circle as many times as we want to, and every time we hit here or here, we pick up another solution. We can't write all those down, so we just put plus 2 pi k after each one, and that takes care of them. Okay, last one here, you've got 4 cosine squared minus 4 cosine plus 1. This is one that you need to factor. So what I did is I converted it to x's and factored it using the x's. So here you might want to do bottoms up method to get to this point. If I was doing bottoms up method, I'd multiply the 4 and the 1 together and I'll get 4. So I'll have x squared minus 4x plus 4. So I'll have x minus 2, x minus 2. I need to divide by my leading coefficient, which is a 4. So x minus 1/2, x minus 1/2. And then remember the bottoms up part to that. So 2x minus 1 and 2x minus 1. So that's how I'm getting this here. Okay, set each one equal to 0. Since they're both the same, I don't have to do it twice. So I get x equals 1/2. So I'm looking for basically, since x was cosine up here, so I'm going to substitute my cosine back in the place of x, and I get cosine of theta is 1/2. So cosine is 1/2 for my pi over 3 angles. Cosine is positive in the first and the fourth quadrant, so I need my pi over 3 angle from the first and the fourth quadrants. In the first quadrant, that is just pi over 3, and in the fourth quadrant, it is 5 pi over 3. So I've got pi over 3 plus 2 pi k and 5 pi over 3 plus 2 pi k. Okay, so that concludes the study guide. If you have any questions, please just reach out to me with an email and we can set up a time that we can meet to discuss any of the questions that you may have. Thank you and have a good day.